All right, good afternoon, everybody. Hope everyone's having a great time at JSConf Budapest. My name is Adam Giese. I'm Adam Giese Dev on Twitter. And before I was a software engineer, I did attend school for music, specifically music composition. And I was always drawn to the analytical thinking aspect of music theory. And perhaps surprising nobody, I had a tough time finding a job in music. And so I went into programming, which I had some experience with. And years later, when I started to learn functional programming, I found that the same itch was scratched regarding the analytical thinking. So when I started to try to get back into music as a hobby, I decided to use functional programming. So here's my introduction to programming, my introduction to functional programming from a musical perspective. So first, we must ask the question, what is functional programming? My answer is, it's programming with functions. Just like object-oriented programs are oriented around objects, functions are the building block of functional programming. But that naturally leads to the next question, what is a function? A non-functional programming definition might be something like a sequence of commands abstracted into a reusable unit. But a more functional definition is a relationship between a set of inputs and outputs. And this is sometimes referred to as a pure function, and it comes from the mathematical definition of a function. And these so-called pure functions are the building block of functional programming. So what makes a function pure? Well, there's two main aspects. Given the same arguments in, it will return the same value. That means it shouldn't rely on anything outside of itself, such as a random number generator, or the current time, or a read from the database. It also means it shouldn't affect anything outside of its return value, such as manipulating the DOM or writing to a database. And together, this makes the function referentially transparent. This means that a function call with the same parameters can be replaced by its return value. So here we are defining middle C with a name and an octave. An increment to octave here is a pure function. It takes a note and it returns a new note with the octave incremented by 1. And high C here is the result of that pure function. Play here is a function that is an impure function because it has a side effect. It sends music to the browser. You can pass in either high C or increment octave middle C, and it'll have the same effect because of the referential transparency of the increment octave function. So we decided to learn functional programming, we remove all side effects, and now your program is useless. It's important to note that side effects are not bad. HTTP requests, DOM manipulation, or playing music are all side effects. They are not bad, but they are unpredictable and they are harder to test. So you need to use your impure functions carefully and predictably. So now that we know what functional programming is and what a function is, what are some tools? One of the main ones is immutability, and that's the idea that a variable state cannot be modified after creation. And you might be thinking, why? Why would you like to tie one arm behind your back? But there is a reason for this. There are some advantages of immutability, such as it's less for your brain to track. Humans have a working memory. It's the biological equivalent to RAM. And if your brain has to keep track of what state a current variable is in, it's more time that your brain is working on that and not spending on the rest of your program. It also, immutability prevents unintentional side effects. You accidentally changing a variable in a function can be a really hard bug to track down. And it preserves state. I like to think of it as your bank account balance. When you sign into your bank account, you don't just see your single balance. You see your current balance, which is derived from the starting balance, and then the withdrawals and deposits. Another technique of functional programming is higher order functions. And that's a function that either accepts an argument, a function as an argument, or returns a function. You might be thinking this is something along the lines of, but here's an example that might help. Here, Tone.js is a framework that's built on top of the Web Audio API, and playNote here is a higher order function. It accepts a note, and it returns a function. PlayMiddleC here is the result of that function being called with C4. AddEventListener here accepts a function as an argument. So AddEventListener and playNote are both higher order. playNote because it returns a function, and AddEventListener because it accepts a function. Now, manipulating arrays is an important part of all paradigms, and functional programming has a lot of really great tools for dealing with arrays. And there's two concepts that we already covered that are important. The higher order functions, because each of these methods accept a function, and immutability, because each of these methods that I'm mentioning will return a new value rather than manipulating the current one. So array.filter. It accepts a function that's run against every element. That function receives the element, the index, and the array, and it returns a subset of the original array. So we define a melody, and we define a function, isHigh, which takes a note and returns a Boolean. If that value is equal to or above middle C, it is considered high, otherwise it is considered low. So high notes is the melody filtered to isHigh. And we get only the elements that return a truthy value. So here we have our unfiltered melody. And when we filter to just the high notes, array.map accepts a function that's run against every element as well. It also accepts the element, index, and array within that function. But rather than returning a subset of the original array, it returns an array of the same length with new values. So we have our melody here, and we have our increment octave function, and then we map our melody to increment the octave. And now we have a copy of the array, but with each note incremented by 1 octave. Or the high melody. And the last one I'll cover today is array.reduce. And array.reduce also accepts a function that's run against every element, but in addition to the accumulator, in addition to the element, index, and array, it also accepts an accumulator value. And it will return the total accumulated value after passing through every element. And in some languages, this is known as fold and accumulate, and it is a more generic tool than filter or map. I often hear that reduce takes an array and returns a single value. And this is true, but I don't consider it to be a terribly useful distinction because all functions in JavaScript return a single value. So I like to think of it as a generic utility function that can return any type, whether it be another array. In fact, you can write filter or map using a reduce, or it can return a single string or a single integer. So I find the best way to learn reduce is really by example. So here we are defining this melody with note names and length. Then we have our toLength function that is going to be passed to reduce. Total is the accumulator, and note is the array element. And then the function adds the total to the value of the note's length. So length, or the reduce, accepts a function and an initial value. and then the return value is the end accumulation. So starting with the initial value of 0, we go through and each note's length is added to the total. So 0 plus 0.125, 0.125 plus 0.125 is 0.25, 0.375, until we get to the total length of 1.625 seconds. So here with our melody, we get 1.625 seconds. All right, now that we're done with arrays, partial application is an incredibly useful tool for writing reusable and generic functions. And it is a technique to preset or fix some of the arguments of a function. So here we have a transpose function. It takes a direction, either up or down, an interval, such as a major third or a minor seventh, and a note, which will be transposed. A major third is a function that is a partially applied transpose. We set up and we set major third, but we wait to receive the note. So here, when passing in C4, up major third will return an E4, or a B flat 2 will return a D3. And there is a way, in stage 1 of the TC39, there is a syntax for native partial application that will let you to partially apply arguments to a function by using the question mark for what you don't want to apply. So down minor seventh can be a partially applied transpose by leaving the note as a question mark. So here we can map these partially applied functions to an array of notes, and here the transposition. Or up a major third, or transpose down a minor seventh. So partial application is a great tool for writing reusable functions that are partially applied. But the real bread and butter of functional programming is composition. And composition is a technique to combine multiple functions into a new function. So here we're going to take a note name, and we'll return the frequency but detune slightly. So we have a function converting a note name to a frequency. For example, an input of A4 would return a number of 440, which is the frequency in hertz of an A4. Detune up will be define a function to multiply by a small percentage. So an input of 440 hertz would return 444.4. And then compose here takes two functions and calls them from right to left. So get detuned frequency is a function that is created by composing detune up and frequency. So an input of A4 would return 444.4. And there's a pipeline operator that's currently in stage 1 of the TC39 spec as well that would allow for easier function composition through piping. So here, you can write a get detuned frequency by piping the note first to frequency and then to detune up. So here we can hear our A4 and the same note but detuned. So now, putting it all together, we are going to be writing a function that converts a human readable shorthand into a computer readable array. So, everyone able to read that? All right, just kidding. So first, we'll be importing some dependencies from Lambda and Tone.js. And this might seem like a lot of functions that we're... My computer just fell asleep. Sorry. All right. Because that means I'm about halfway through, because I think it's such a 15-minute. So first, we're importing some dependencies from Lambda and Tone.js. And we're going to define some functions by function composition. So here, parse name takes a shorthand note, and it returns a name. For example, C4 at 8n would return a string of C. It pipes the input through two other functions, match, which will return an array of matching strings that match the regex, and head, which will return just the first string. So when passing C4 at 8n, the match function would return an array of the string of C, and then the head function will take that array of the string of C and returns just the string of C. So C4 at 8n to array of C4 to just C. Parse octave here works similarly. It takes a shorthand note and it returns an octave. So C4 at 8n will return an array of the string of 4, which will return the number 4. And parse duration takes a shorthand note and returns the duration. It splits at the @ symbol, and it takes the last string, so in this case, an 8n. Parse time here is a little bit more complicated. It takes a note and its context within the array, and it will return a scheduled time. So it takes the array of notes, it slices the array to only those notes preceding your current element. It maps each of those notes to their length, and it reduces them to a single value, in this case a number. So altogether, this lets the Web Audio API know when to play each note by adding the time of all of the previous notes. And now, parse shorthand is a composition of compositions. It accepts a string, and it returns an array of objects that is able to be consumed by the Web Audio API through the Tone.js. First, we split at all white space. This turns the string into an array of strings. And then array map we pass it the array of strings, and that converts it to an object. So apply spec takes an object shape with functions, and each string in the array will be passed into each of these functions, and it will be mapped to an object of a matching shape. So what will be returned is an object with a name with a value that takes each of those strings and passes it to parse name for the name, parse octave for the octave, parse duration for the length, and parse time for the time. So with our parse shorthand function, this input string becomes this array of strings, passed to apply spec becomes this array of node objects, where we have the name, the octave, the length, and the time. So this string can become this music. Or this string can become this music. So why should you care about functional programming? I like functional programming because it forces you to break down problems into their smallest parts. When converting a string into music, we had to think of how to parse this shorthand in a way that the computer could read it. And there's a lot of parts there, but we didn't write very many functions. There was only one function that was actually written. Most of the functions were defined by just piping together very small functions, like like regex match or a first or a conversion from a string to a number or an add. So it forces you to break down problems into their smallest parts. So if you found this interesting and would like to go further in functional programming, there's some really great resources. Professor Frisby's Mostly Adequate Guide to Functional Programming. It is definitely a more than adequate guide. It's available for free online. Professor Frisby is known as Dr. Boolean on Twitter. He's got some great video resources as well. Also, I would highly suggest looking into a functional utility library. In this case, I used Ramda. Lodash FP is a branch of Lodash that has a lot of really great utility functions that have a functional programming perspective. And LambdaCast is a really great podcast for going over the fundamentals of functional programming much more in depth. Thank you so much for your time. If you have any questions, feel free to catch me afterwards or message me at Adam Giese Dev on Twitter. Thank you. Can I take my...